I will introduce the history of INNO implant system and key technology. In 1990s, implants were placed in the healed edentulous ridge. Bioplant system was developed with RBM sandblast rough surface. In 2000s, the marginal bone change was minimized with the platform switching connection. Outlaw system was developed with anodic spark deposition surface. In 2010, implants were immediately placed in the extraction socket. INNO system was developed with RBM sandblasted and hyperthermal exit edge surface for early bone growth. The key technology of INNO implant is design and surface treatment. The first factor is the individual design of final drills and fixtures according to length and diameter, which establish the initial implant stability even in the extraction socket and the shallow sinus bone. In addition, the platform switching connection prevents the marginal bone loss during functional loading. The second factor is the macroscale and microscale hydrophilic rub surface, like as the etched enamel surface of tooth. This surface stimulates osteoconduction of osteoblasts. The commercially thermal exit etching implants were compared with INNO implant system. INNO implant system has the well distribution of macro and micropores, but in the others, the distribution and porosity of etched surface are not reached to INNO system surface quality. INNO implant system is hydrophilic surface. After alkali solutions cleaning, the oxygen element surface energy is maintained in high energy status. In static water contact angle measurement, the water contact angle is 36 degrees, which means hydrophilic below 45 degrees hydrophilic criteria. In hydrophilic surface of INNO system, fibronectin in whole blood could be spread and coated in the thin and uniform film pattern which osteoblasts attach and proliferate. But in hydrophobic surface, fibronectin is coated in the thick and irregular film at the black dot. In the animal experience of dog's mandibular edentulous ridge, osseointegration of INNO SLA surface treatment was evaluated with machined and anodic spark deposition surface on 8 weeks after implantation. INNO SLA surface treatment shows the higher bone implant contact surface percentage in statistical difference than machined and anodic spark deposition surface. INNO hydrophilic SLA surface has the high potential of bone regeneration in extraction socket. Immediate implant placement and simultaneous socket bone graft is safe and successful in INNO system. At conventional loading time, the new bone around implant was remodeled and there are no marginal bone loss. Immediate implantation and bone graft in extraction socket was done in 46 implants. After average 80.6 months after implant placement, one of 46 implants was failed. The survival rate was 97.81%, which is not statistically different with length at all. 46 prospective studies, which reported from 97.3 to 99% survival rate. Marginal bone change of immediate placement was 0.014 plus minus 0.009 mm in no significant difference with 0.036 plus minus 0.024 in late placement. Final drills are customized according to the shape and size of fixture. For extraction socket and infrasinus ridge, the discrepancy diameter of the apical and crestal portion in the fixture and drill were calculated from clinical application and model analysis. Final drill is composed of diameter 3.5 or 4.5, 6 mm fixtures final drills according to diameter and 8, 10, 12, 14 mm fixtures final drill in length. In the shank of drill, the 4.0 mm width and the 10 mm length final drill is marked as diameter 4.0 by 10. In extraction socket, INNO system could be anchored up to 25 Newton-centimeter torque force in minimal 3 mm depth of bone. In the extraction socket, a mandibular posterior tooth, INNO system could be immediately placed with the simultaneous bone graft, which shortened the loading period. In infrasinus shallow ridge, INNO system could be anchored up to 25 Newton-centimeters torque force in minimal 3 mm depth of bone. In infrasinus shallow ridge of maxillary posterior tooth, INNO system could be immediately placed with the sinus bone graft, which shortened the loading period. INNO surgical kit could support the crestal approach in sinus bone graft. The point drill marks the position of implants. Length 8 mm initial drill has the steps in 4, 5.5 mm. Under 500 rpm speed, each steps could be stopped at crestal bone which elevates Schneiderian membrane without perforation. Length 8 mm final drill of various diameter fixture has the steps in 3, 4.5, 6 mm from the apex. Under 300 rpm speed, each steps could be stopped at crestal bone which elevates Schneiderian membrane without perforation. From 4 mm diameter final drill sequentially to 5 mm diameter final drill, the hole could be widened for easy to insert bone particles. The final drill could be inserted in reverse direction for prevention of Schneiderian membrane perforation with irrigation. Mini periodontal curette could elevate the Schneiderian membrane around drill hole in direction of mesial, distal, buccal, and palatal side. Osteotomy instrument could insert the bone particles into hole. The full depth of final drill is inserted with the reverse direction and under 300 rpm speed without irrigation, which spread bone particles around the elevate space and prevent the escape of particles from hole. In dense sharp cortical bone, the initial drill and final drill has stopper with crestal cutter which flattens the sharp edge. The countersink drill widens to 0.2 mm in final drill's hole to prevent the compressive marginal bone loss. Without countersink drill's preparation in dense cortical bone, the diameter 4 mm fixture might be placed by over 80 Nm torque force, and the diameter 5 mm fixture might be inserted by about 150 Nm torque force. It is reported that the high compressive placement of fixtures could induce the failure of osseointegration due to the surrounding bone's necrosis. For prevention of compressive bone necrosis, the gap between fixture and final drill hole has to be enlarged by countersink drill. On no countersink drill uses, marginal bone is lost during healing time, but there is no marginal bone loss in countersink drill uses.